Hey y'all, Miss Brown here, your 8th grade pre-AP science teacher. Okay, so I'm here to read you the Unit 1 Topic 2 quiz, calling it a quest because it's kind of like a quiz but kind of like a test. And it's on plate tectonics, and actually it's on plate tectonics and plate boundaries. So I am going to read it to you from inside the student view. So I have to answer the questions in order to move on. So I'm going to tell you that I'm choosing the last answer on every question just so that I can move on. Okay, last name is Brown. First name is Gina. And I will pick first period because I don't have any first period 8th graders. So let's get started. Number 1, ocean crust when compared to continental crust is what? And remember my little hint. Ocean crust is like ocean eyes, Billie Eilish. So think of young, thin, but kind of dense. Think of like the young adults in this world as kind of dense, a little self absorbed, maybe. Yes, I'm being judgy, but yes, I'm making it up. It's just for remembering's sake. Then remember, like I've said before, grandma reminds me of continental crust because grandma, she's thick. She's brittle, she's got a cane, she kind of walks real slow. So I'm thinking that continental crust reminds me of grandma, and ocean crust reminds me of ocean eyes, Billie Eilish. Okay, so ocean crust, when compared to continental crust, is what? So is ocean crust older than continental crust? Is it younger than continental crust? Is it less dense than continental crust? Or is ocean crust the same age as continental crust? So remember, I'm just picking the last answer so I can move forward. So number 2, as Earth's plates move, which of the following form along the boundaries? So as Earth's plates move, what is forming along these boundaries? Are mountains forming? Are volcanoes forming? Are rift valleys forming, or are all of the above forming? So mountains and volcanoes and rift valleys. Remember, I'm just picking the last one. Number 3, plates separate or move apart at this boundary. And here is an image to show you moving apart, separating. Is that convergent boundaries that move apart or divide? Is it divergent boundaries? Is it magnetic boundaries? Or is it transform boundaries? And try to be using test-taking strategies, for example, eliminating answers that you know are not correct. If you haven't heard me talk about it, it's probably not a type of boundary. Number 4, a convergent boundary occurs where two plates do what? A convergent boundary. Kind of giving you a little hint of what occurs at a convergent boundary here as well. So, do convergent boundaries move towards each other? Move away from each other? Move past or side by side each other? Or do they move over one another? A convergent boundary. Number 5, a common geological feature found along divergent plate boundaries in oceanic crust is the formation of a what? So, what geological feature is found at a divergent boundary in ocean crust? Is it a trench? Is it a mountain? Is it a mid-ocean ridge? Or is it an island? Cute little turtle. So remember, y'all, I'm just picking the last one so I can move forward. And then you hit next. But remember, you can always go back. So for instance, if you kind of find another piece of information out further in the quiz or the quest, you can always go back and kind of adjust your other answers. So try to find clues in the test as well. Also, stand up, stretch, take a break. Go grab a drink of water too. Water helps your brain kind of get everything working. Little brain breaks are perfect to refresh your energy. So use the figure below to answer questions 6, 7, 8, 9, and 10. Be sure to study the figure closely before answering questions. So number 1, this says mantle. Number 2, it looks like this is pointing in between this sort of volcano. Here's the ocean. This is number 3, this mountain. Number 4 is right here. Number 5 is under the mountain pointing at this plate, and check out the arrow. And then number 6 is referring to this plate right here. So number 6, the continental crust located at point 3 in the diagram rides on top of the oceanic crust because. So the continental crust located at point 3 in the diagram. So they're talking about this. Why does this continental crust ride on top of the oceanic crust? Because continental crust is more dense than oceanic crust. Because continental crust is less dense than oceanic crust. Because continental crust formed after oceanic crust. Or because continental crust is older than oceanic crust. Why does the continental ride on top of the oceanic? Number 7, the process of the oceanic crust being pushed under the continental crust in point 4 is called what? So this crust right here, the process of the oceanic crust, and we can tell it's oceanic crust because it's in the ocean. So what is this called when it gets pushed under this continental crust right here? Is that called metamorphism? Is that called asthenosism, subduction, or convection? And once again, y'all, if you've never heard me say these words, probably not right. Number 8, point 4 will most likely result in what? So right here, this oceanic plate going under this continental plate, what is going to form right here? And you need to think, is this plate and this plate, are they converging? Are they diverging? What's going on? And then why is this plate going under? And then what's going to form right here? Is there going to be a volcano, a mountain, some new seafloor, or an earthquake? And which one's most likely going to result? Number 9, which of these best describes what's happening at location 6? If I go back up, at location 6, right here, this oceanic plate, from the other question, you need to figure out what it's doing. And then they want to know what's happening right at 6. Is an oceanic plate being created? Is a continental plate being created? Is a continental plate melting? Or is an oceanic plate being destroyed? Point 6. So you need to first ask yourself, is this continental or oceanic? Then you can eliminate some of the answers. And then when it goes under here, what is going to happen to it? So use your test taking strategies. Number 10, the newest rocks are found where? 2, 4, 5, or 6. The newest rock. So you need to look at this diagram. Is it found here at 2, here at 4, here at 5, or here at 6? New rock. 2, 4, 5, or 6. And remember, I'm just picking the last one for all of them. Number 11, a transform boundary forms when two plates move how? So remember our hand signals and transformers. What do? Do they move towards one another? Away from one another? Do they move past or side by side? You could also say slide past one another. Or do they move over one another? Number 12, the continental crust compared to the oceanic crust is what? So this reminds me of that first question, but now we're comparing continental first. So is continental crust thicker and more dense than oceanic crust? Is continental crust thinner and less dense? Is continental crust thicker and more dense? Or is it thinner and more dense? So remember, I compared continental crust to grandma. Think about what I said about her. And then oceanic crust is like Ocean Eyes, Billie Eilish, young people. And obviously, that's a huge generalization. It's just to help us remember. Number 13, what type of plate boundary exists in California along the San Andreas Fault? And here is an actual picture of the San Andreas Fault where it starts. So they've got a little sign and everything. So is there a divergent boundary at a fault? Is there a convergent boundary at a fault? Or is there a transform boundary at a fault? Think about San Andreas Fault, think about your hand motions, what happens in California a lot, and which one of those boundaries is responsible for that. I must say, y'all, I found some pretty great pictures for this quest. Number 14, when volcanoes form, magma or melted rock rises from underground. This magma comes from Earth's what? Does it come from Earth's crust? Does it come from Earth's mantle, the magma in a volcano? Does it come from Earth's outer core? Or does it come from Earth's inner core? Where does that magma come from? Number 15, at what type of boundary do earthquakes occur? So think about earthquakes, think about your hand motions. Do earthquakes occur at all of the boundaries? At just convergent, just divergent, or just transform? So think about, when have you heard me talk about earthquakes, and was it just one boundary type or more than one? So remember, y'all, I'm just hitting the last answer choice on every question so I can move forward. Because if I show you from my copy, it gives you the answers. Okay, take a little body break. Stand up. Do 10 jumping jacks or push-ups or sit-ups. Get that oxygen flowing. Grab another drink of water. Hydration is the key to a healthy body and mind. Check out these kids. They know what's up. Okay, y'all, so you're going to use this diagram below for the next 5 questions. So please make sure that you keep scrolling back up. So I have continental crust here, continental crust here. This is the water line. So this is all under the water, y'all. This volcano is under the water, this trench, and this is the mid-ocean ridge. You've heard me talk about that before. So number 16, based on the theory of plate tectonics, what feature is formed where a continental plate and oceanic plate collide? So when you have a continental plate colliding with an oceanic plate, what would you have form? Would you have a mid-ocean ridge? Would you have a trench? Would you have a rift valley? Or would you have sea mountains? So you need to think. If continental plate is continental grandma or Billie Eilish, and then think oceanic plate, grandma or Billie Eilish, and then which one's more dense? What's going to happen when they collide? Are they going to form mountains? Are they going to form a rift valley, which is like big old hole in the ground? Are they going to form a trench? Or are they going to form the mid-ocean ridge? Okay, number 17, new ocean crust is being produced along the blank, while old crust is being pushed back into Earth along the blank. So new ocean crust is being produced where? On the mid-Atlantic ridge, on convergent boundaries. Is new ocean crust being produced in rift valleys? Or is new ocean crust being produced in a subduction zone? New crust. So y'all notice what I did. I just did this first part of the question first. There's no point in going to the second part until you figure out what the first part is. And then if I think it's one of these, for instance, let's say I think it's subduction zone, and then I read this second question and that doesn't make sense with hotspot, then I know it might not be right. So it's good to break it up. while old crust is being pushed back into Earth along the what? Is old crust pushed back along the trenches? Is old crust pushed back along divergent boundaries? Is old crust pushed back along volcanoes? Or is old crust pushed back along the hotspot? So, first blank, this first word, second blank, this second word. Once again, I'm just clicking that last one so I can move on. Number 18, which of the following or which of these explains best, so y'all, that is bad grammar on my part, my apologies. So, which of these explanations, that's why I just can't read, y'all. Which of these explanations best describes what is happening at the boundary labeled trench? So, right here, y'all, what is happening at this boundary? Are two continental plates colliding and creating folded mountains? I'm going to make this a little smaller so that way we can kind of still see it. Take a second. Okay, let's see if we can still see it. One more small. And one more. Okay. So which of these explanations best describes what's happening along the trench? So right here, what's happening at this trench? Are there two continental plates colliding to create folded mountains? Are there two oceanic plates colliding and buckling up the seafloor and creating new crust? Along this trench line, is the continental plate and oceanic plate colliding and the oceanic plate is being subducted? Or along the trench is the continental plate and oceanic plate colliding and the continental plate is being subducted? '19. Which of these explanations best describes what's happening along the boundary labeled mid-ocean ridge? So what's happening right along here? Are two continental plates colliding and creating folded mountains? Are two oceanic plates diverging and creating new crust and seafloor? Is there a continental and an oceanic plate colliding and the oceanic plates being subducted? Or is the continental plate and oceanic plate colliding and the continental plates being subducted? So y'all notice how those have the same answer choices. So keep that in mind. So mid-ocean ridge is right here. Notice how it's under the water. And then you need to look and try to eliminate some of those answers. Number 20, choose a crustal feature caused from plate tectonics. Describe what plate boundary or boundaries that feature occurs at and why. Choose one from the following. So basically, y'all, tell me about a trench, what kind of boundaries make it, and what feature occurs there. A volcano, what kind of boundary happens? Mountains are what type of boundary? Mid-ocean ridge is what type of boundary? Rift Valley is what type of boundary? Or an earthquake? So you're choosing this feature and you're telling me what type of boundaries make this feature and why. Okay, y'all, just a little more to go. You got this. Don't forget, you can look back at your previous work before you submit. So that's a little hint to go back and kind of look at the questions to see if you can snag some data. Read the prompt below and answer in complete sentences. Be sure to restate the question and include details and evidence in your response. So the continents of Earth fit together like a puzzle. The east coast of South America fits closely with the west coast of Africa. So you have these continents fitting close together. Explain why the continents of Earth appear to fit together like a puzzle. In your explanation, be sure to include. So tell me, what's the process responsible for the current position of the continents? And then what are some other supporting evidence? So y'all remember there's 4 pieces of evidence from Alfred Wegener's theory. So tell me, what is the process responsible for this? So Alfred Wegener's theory, and what are his 4 pieces of evidence? And you're going to answer in a short answer. Number 22, the diagram below shows a model of the movement of 2 tectonic plates. When the plates collide, what determines which plate moves below the other one? So I'm seeing this oceanic plate subducting under this oceanic crust or plate. Why does this one subduct? The younger, less dense oceanic plate will subduct. The thicker ocean crust will subduct. The older, more dense oceanic plate will subduct. Or the younger, more dense oceanic plate will subduct. Remember, y'all, I'm just picking the last one for all of them. Number 23, 4 students were asked to identify how geological features pictured below occurred. Which student correctly identified the geological process that formed the Himalayan mountains? So these responses are in regard, well, their responses and an image of the mountain range are shown below. So here's this mountain range, right here, the Himalayan mountains. And student 1 says the 2 continental plates converged. So these 2 plates converged. Number 2, an earthquake in a subduction zone. So these mountains formed from an earthquake in a subduction zone. Number 3, a tectonic plate moving over a hot spot. So these mountains formed from a tectonic plate moving over a hot spot. Or number 4, the movement at a transform fault boundary. Transform fault boundary. So who is correct? Student 1, student 2, student 3, or student 4? And that is in reference to this, and this. Okay, number 24, the model below shows 2 plates moving towards each other. The Aleutian Islands are a result of which type of boundary and why? So what type of boundary is 2 plates moving towards each other? Is that a divergent boundary creating volcanic islands? Is that a convergent oceanic and continental creating a subduction zone to form the islands? Is it 2 oceanic converging crusts of different densities and they'll have subduction and form the islands? Or is it transform boundaries sliding past one another and pushing the islands into an arc shape? So y'all, my biggest hint is this one's moving here, this one's moving here. What type of boundary is that? Is it divergent? Is it convergent? Is it convergent or is it transform? So you can eliminate some answers just based off of that. And remember, y'all, I'm just picking this last one for all of them. Number 25, which geological feature is most likely to form a mid-ocean ridge? So y'all, that reminds me of, it's back from the other one, but that other chart that we were looking at. Which geological feature is most likely responsible to form at a mid-ocean ridge? The thick black lines on the map show the locations of the mid-ocean ridge. So these are the mid-ocean ridge. Is the geological feature going to forming on the mid-ocean ridge a peninsula, a delta, a plateau, or a volcano? Number 26, rifts are caused from blank boundaries, whereas trenches are caused from blank boundaries. So rifts are caused from convergent, divergent, transform, or divergent. So you need to pick one of those first. And for example, if you think it's divergent, then you have to pick between these 2 choices. Rifts are caused from blank boundaries, whereas, meaning otherwise or opposed to, trenches are caused from what boundaries? So the Marianas Trench in the ocean, is that caused from divergent, convergent, or transform? So figure out one at a time and then you can eliminate. Remember, I'm just picking the last one for all of them. Number 27, according to the table, as the magnitude of the earthquake increases, the distance the tremors will be felt does what? So y'all, this table below shows how far away people can feel tremors from the earthquakes of different magnitudes, which means strength. So the table also shows how many times a year each earthquake at different magnitudes occur. So you're going to use the table to answer the question, As the magnitude of the earthquake increases, what happens to the distances at which you can feel the earthquake happen? So at a strength of 3, the distance from the earthquake can be felt 24 kilometers away. At a magnitude of 4, which is more than 3, you can feel it 48 kilometers away. So it doubles. At a magnitude of 5, so we're getting bigger magnitude, it can be felt at 112. So that's pretty much double again, more actually. At 6, it's 200. At 7, it's 400 kilometers. And at 8 magnitude, it's 720 kilometers. There's only one 8 magnitude a year, 18 7 magnitudes, 126 magnitudes, 800 5 magnitude earthquakes, over 6,000 4 magnitude earthquakes, and almost 50,000 at 49 3 magnitude earthquakes. So according to this table, the magnitude of the earthquake increases. What happens to the distance the tremors are felt? Are the distance the tremors felt also going to increase? Are they going to decrease? Are they going to increase then decrease? Or are they going to remain the same? 28, using the table below, if an earthquake with a magnitude of 2 occurred, how far away from the earthquake would the tremors most likely be felt? So that means use the table above, so I'll edit that. So according to this table, if an earthquake with a magnitude of 2 occurred, how far away from the earthquake would tremors most likely be felt? So y'all, I can't even help, I can't point or anything. So magnitude of 2, how far away would the earthquake be felt? Would it be felt more than 112, between 48 and 112, between 24 and 48, or less than 24 kilometers? And notice how 2's not on here, y'all, so you need to kind of extrapolate based off of what you have. 29, the map below shows the positions of the volcanoes in Burning Ring of Fire. Which locations around the Pacific Ocean? Let me back that up. I was singing and I got distracted. The map below shows the positions of the volcanoes in the Ring of Fire, which are located in and around the Pacific Ocean. So here's the Ring of Fire. According to this map, which of the following most describes where volcanoes are most likely to form in the Ring of Fire? So volcanoes are the dots, and the lines is the Ring of Fire, or the plate boundary. So the question is saying, according to this map, which of the following most describes where volcanoes are going to form? Are they going to form in the middle of the plate? Are they going to form, volcanoes are going to form below the surface of the plate? Are the volcanoes going to form where the tectonic plates meet? Or are the volcanoes going to form where earthquakes are least likely to occur? And number 30, what will happen if this movement continues for the next millions of years? So what's going to happen if whatever movement's happening here continues for millions of years? So the African plate is moving toward the Eurasian plate. So this African plate is moving here toward the Eurasian plate. What is going to happen? Volcanoes will form and erupt at the plate boundary. The Mediterranean Sea will shrink and mountains will form. The African plate will force the Eurasian plate to break in several places. Or the size of the Mediterranean Sea will increase and mountains will form on both sides. So what's going to happen if this African plate continues to move towards this Eurasian plate? And remember, y'all, I'm just picking the last answer for all of them. So it's bringing me back, y'all, because I didn't answer these. I was going to say, I thought I only had 30. So I'm going to hit ... because I forgot to answer that question. So that's cool. It pops you back. Okay, next. So y'all, you did it. Congrats. Go back and double check your work before you hit submit. But here's a little bonus question. So calculate the density of the sample of ocean crust with the following data. So if the volume is 8 centimeters cubed and the mass is 19.384 grams, and density equals mass over volume, what is the density going to be? And you can just put the number if you want, that's fine, but the unit would be grams per centimeters cubed. And that's it, y'all. I'm not going to hit submit. Yeah, I will. I always say that, and then I always hit submit anyways. And then you're all set, and it should send you your answer. I don't think I'm going to have it send you the correct answers yet because I want people to have retakes before you have the opportunity to see what the answers are. Hope that was helpful, y'all.